Hi everyone, it's Laur Fisher from MIT's Today I Learned Climate. Soon we've got 2 brand new episodes coming up to answer questions that we've received about hydrogen energy. So this week, we thought we'd re-air an episode from our 4th season that provides an introduction to hydrogen. This is a great primer on what hydrogen is, how it's made, what it could be used for, and why so many people are talking about it now as a clean fuel of the future. Oh, and keep an ear out for around minute 8 when we talk about how hydrogen is manufactured, because we're going to go into a lot more detail on that in the 2 episodes to come. All right, enjoy. Hello and welcome to Today I Learned Climate. I'm your host, Laur Fisher of the MIT Environmental Solutions Initiative. In season 2 of the show, we covered all kinds of energy sources. Ones that we already use, like fossil fuels and wind and solar power, and ones that we might use someday in the future, like fusion. In this episode today, we're going to talk about another option that maybe you haven't heard of yet, or might just be starting to hear about: hydrogen.
Hydrogen is very versatile. Hydrogen can be used in electricity generation. Hydrogen can be used for heating, for transportation. There is a lot of testing on how hydrogen can be used even in airplanes. And the burning of hydrogen will not produce that nasty carbon that we don't like. I'm Svetlana Ikonnikova. I'm from the Technical University of Munich with a School of Management, Center for Energy Markets, but I'm also a researcher at the Bureau of Economic Geology at the University of Texas at Austin. I analyze different energy resources, how we use them, and how we want to use them in the future.
Hydrogen is emerging as potentially a really important way for us to reduce carbon emissions. But what is it, and how can we use it? And why haven't we heard more about it? That's what we'll cover in today's episode.
Hydrogen has atomic number 1, so we all probably know it with a periodic table. So this is colorless, tasteless, and odorless non-metallic gas. Hydrogen is also highly flammable, and so we can burn it. If we can burn it, we can make energy. But pure hydrogen does not occur a lot on our planet Earth. And so to be able to get that gas, we need to split substances into simple parts to extract the hydrogen.
Yeah, first we have to actually make hydrogen gas before we can use it. This is unlike our current energy sources, right? Like coal, natural gas, oil, uranium, sunlight, wind, water, which we can find on our planet. It seems strange to think about doing this. Like, why would we take the extra step of producing hydrogen gas in order to use it? But we already do this all the time with electricity.
Electricity can help us to drive cars, to use our laptops. But in order to get electricity, we have to do some work. We have to burn gas or coal or have the hydroelectric generation.
This is why hydrogen and electricity are called energy carriers and not energy sources. Now, electricity has so many benefits that it's worth generating it. The same is potentially true with hydrogen. We'll get back to how we produce hydrogen in a minute, but first, let's talk about how we can use it.
Hydrogen is so versatile that we can really try to substitute it across all the main sectors we usually talk about as we talk about the CO2 or any other greenhouse gas emissions. We can use it in transportation, and currently there have been tests for using hydrogen in shipping, in airplanes, in road vehicles, trucks specifically. Hydrogen can be used in electricity generation. Hydrogen can be used for heating. It can go directly to your boiler to heat up your water. We can also mix it with natural gas itself and just reduce the concentration of carbon.
Yeah, so you can blend hydrogen with the gas that many people already are burning in their home hot water heaters or furnaces to create a lower carbon version. This is kind of like how currently ethanol is blended with gasoline and used in car gas tanks today. We could also burn hydrogen instead of fossil fuels for industrial processes like making steel, where you need a lot of consistent and reliable heat, which can be difficult to get entirely from clean energy.
It's definitely been already proven that we can use hydrogen to reduce the use of natural gas and coal in steel manufacturing in order to make the process cleaner.
This is what makes hydrogen gas so appealing. It can do most of the things that currently only fossil fuels can do, but unlike fossil fuels, it doesn't release CO2 when burned. And there's potentially another important use of hydrogen.
Hydrogen, just like some other energy resources, could be stored for a long time. We like the renewable resources, but at the moment we do not have a good solution to store the electricity.
Yeah, so hydrogen could actually complement wind and solar by storing electricity that can be used when the wind isn't blowing or the sun isn't shining. Okay, so now let's talk about how we actually produce energy from hydrogen gas. Generally, you can either burn it for heat or power, like we do now with natural gas, or use it to generate electricity using something called a fuel cell.
Fuel cells actually been known to the humankind for close to 200 years. In the beginning of the 19th century, Sir William Grove figured out that if you apply electricity to water, you can split the water molecule into oxygen and hydrogen. And he got to an idea that you can apply a reverse reaction in order to bring the two things back. So just as you use electricity to split the oxygen and hydrogen, if you bring hydrogen and oxygen together, you can produce electricity and water, steam. The hydrogen we usually get from some hydrogen tank. And then we have oxygen that we typically would get from air.
So hydrogen gas goes in one end of the fuel cell, and that produces electricity, heat, and water vapor. Compare this to a gas-powered car where gasoline goes into the engine, but in addition to power, you also get CO2 and other pollution. In fact, there are hydrogen-powered cars, and we have some links in our show notes if you want to learn more about them. But fuel cells have other applications too.
These days, fuel cells used in big power generation plants, like for instance in South Korea, recently they had installed hydrogen plant that can power about 250,000 homes. So like a small city. So it's about 80 megawatt plant. And now we developed the fuel cells that could be so small that you can use in your laptop or even try to use it in your cell phone.
So hydrogen sounds pretty great, right? And producing hydrogen isn't just happening in a lab right now. Industries already extract it and use it for things like fertilizers and oil refining. But if we want to scale up the use of hydrogen for clean energy, it's important to consider how we get that hydrogen.
Hydrogen occurs naturally very rarely, but more frequently we can have hydrogen in different combinations with hydrocarbons, oxygen, many other chemical compounds.
Remember that everything is made out of molecules, and those molecules are made out of atoms. Hydrogen gas is 2 atoms of hydrogen, H2. Because this molecule doesn't exist naturally on planet Earth very much, we need to pull it out from other molecules.
We take some molecule where hydrogen is. The very simple one that we may think about is a methane or natural gas. So the formula for this is CH4. So we have 1 atom of carbon and it holds 4 hydrogen. We can split the 2 and then put the carbon away in some shape, and then we have hydrogen. Currently, about 95% of hydrogen is produced from methane, which means that we have as residual carbon dioxide. So that carbon goes back into atmosphere. It's polluting. This hydrogen we don't like. That hydrogen will not be a solution. We see the solution in the hydrogen only if it helps us to capture the carbon if we use the fossil fuels, and then utilize it, or store it, or sequester it, do something with that.
We have an episode on carbon capture and storage if you want to learn more about this. But there is a way to produce hydrogen without producing carbon.
If we use renewable energy, we can produce much cleaner hydrogen. There is no carbon residual. In really simple terms, if you take the water and you put the current through it, you will start breaking the chemical linkages between the hydrogen and oxygen as chemical elements.
This is kind of like a reverse fuel cell. Water and electricity go in, hydrogen and oxygen come out. One of the things that makes hydrogen so appealing is that, like electricity, it could potentially be produced anywhere.
If you have nearby fossil fuels, you can produce it from fossil fuels. If you are somewhere where you have wind or solar, you can use wind and solar and water and produce hydrogen once again.
And if it can't be produced somewhere, for example, if you don't have a lot of fresh water or electricity, you can move it around.
You can transport hydrogen, in some cases almost as efficient as natural gas.
So often something that we hear about when we're speaking with scientists about climate change is that there's no silver bullet. There's no one technology that's going to come and save us, and that's what we should be investing all of our money in. But is hydrogen this silver bullet, given how versatile it is?
As much as I like hydrogen, I would agree with all those scientists who say that there will not be a unique solution for us. And hydrogen is most likely, we believe, would be a big portion of the solution for the future, but not its sole and potentially not even a primary part of it.
And that's for many reasons. Hydrogen is currently more expensive than other low-carbon energy options like wind and solar. Scaling up the development of pipelines and other infrastructure is also a challenge. In some conditions, when you burn hydrogen, it produces nitrogen oxides, which is a different kind of greenhouse gas. And hydrogen is also extremely flammable. It ignites more easily than methane gas or gasoline. Overcoming these challenges would mean convincing a lot more people to spend time, money, and effort on hydrogen.
There are many different projections coming from the leading energy agencies around the world. Almost all of those agencies show a really wide uncertainty gap around what may happen. And the issue is not just in how much would it take to increase the production of hydrogen. It will depend on how fast we can grow production of the renewable energy, because we don't want to expand to a large degree use of fossil fuels just to convert them to hydrogen. We're still on the earlier stage in exploring its possibilities, and so we shouldn't look into current hydrogen development as a signal to whether it has a bright future or not, but rather get some patience and take another decade until we see how it will unfold.
That's our episode for today. If you haven't listened to our season 2, I highly recommend that you do. It is all about energy and climate change, explained in a way that we can all understand. As always, we have an accompanying educator guide to help teach about hydrogen in middle school and high school classrooms. You can find it at climate.mit.edu/educators, or for free on the popular site Teachers Pay Teachers. TIO Climate is produced by the MIT Environmental Solutions Initiative at the Massachusetts Institute of Technology. David Lishansky is the editor and producer. Aaron Krol is our associate producer and did our artwork. Ilana Hirschfeld was our production assistant. Natalie Jones was our scriptwriter for this episode. Michelle Harris did the fact-checking. Sylvia Scharf is our climate education specialist. The music is by Blue Dot Sessions, and I'm your host and producer, Laur Hesse-Fischer. A big thanks to Professor Svetlana Ikonnikova for speaking with us, and thank you for listening.